Okay. But example na agad. So, yeah. Turbine. So, this is the condition curve for the turbine. So, testing nyo, so, siyempre, nasa MLab tayo. So, ito napaka-importante talaga. Pag-plot ng performance condition curve ng turbine. Every point. A curved line drawn through points 1, 2, 3, 4, 5, 6, 8, indicating the condition of the steam throughout the turbine at points where it is possible to extract and measure the steam properties is known as the condition curve. The condition curve does not represent the path of the steam on Mollier diagram during its flow through any particular stage of the turbine, but indicates only the properties of the steam entering and leaving the stages of the turbine. So kaya nga small letter to, that is per pound. Okay? Hindi siya actual na BTU, okay? O kilojoules. Ang unit niya is either kilogram or per kilogram or per pound. So stage efficiency has been defined as the ratio of actual enthalpy drop across the states ito, bawa to the isentropic enthalpy, 2 to 3 prime, drop for the same pressure differential. When this ratio is applied to a group of blades or to the entire turbine, it is referred to as the Rankine cycle ratio, RCR. Pag-binaw mo na to. Yan. Tapos yung 9, ito ng isentropic. Okay? Or the internal efficiency of the turbine. So, turbine ang pinag-uusapan natin buo na. Pero pag sa loob, meron tayong stage efficiency, turbine blade. So, sa labas ng turbine, yung buong turbine is internal efficiency of the turbine. Okay, so this expression does not include such mechanical losses as bearing losses, oil pump, power, etc. So, pag in-include mo yun, so ibig sabihin, mechanical din yung efficiency na yan. In which N sub mg equals mechanical engineering efficiency, or engine efficiency now is RCR times N sub mg. Yung symbol to at natawag ko lang na N. Kasi para di madali hanapin. Tsura siyang N. Okay? Engine efficiency is Nmg times H1 minus H8 over H1 minus H9. So this is now the formula. So ito yung mga rating. Theoretical steam rate is TSR is equal to 341P over H of 1 minus H of 9. Theoretical. So ano yung T41P? T41P, ang actual unit niya is BTU horsepower, BTU per kilowatt hour. Okay. Tama. Kasi nga, saan tayo sa power? Pag power at is, produce ka ng power is a kilowatt. Then the actual steam rate is SR is equal to 341P over H1 minus H9 times N sub Fg over RCR, or SR is equal to TSR over N sub Fg divided by RCR is equal to TSR over the engine efficiency. So this efficiency have been developed to conform the generally accepted usage in practice and to include the generator losses. So may mga table naman generator losses. Pag begin mo sa problem, say, okay, if the turbine is of the mechanical drive, so hindi siya magpo-produce ng power sa consumers, produce siya ng power to drive a machine, then the generator efficiency will have no significance kasi wala sa generator. The expression would then be based on horsepower. Okay, the thermal equivalent of horsepower is 2,545 BTU per hour. Would be substituted for 341. Okay, and SI, this is kilojoule per kilogram. So this now become 3,600 kilojoule per kilowatt hour. So sa English kasi tayo, okay? So sa SI, ano yan? 3,600 kilojoule per kilowatt hour equals to 3413 BTU per kilowatt hour and 2545 is BTU per horsepower hour. Meron pa dyan, 42.4 BTU per horsepower minutes yata. Check nyo lang sa mga conversion table. So example, number 10. At 3,600 RPM, 60,000 kilowatt unit receives steam at 385 PSI gauge. And 800 Fahrenheit with a back pressure of 1.5 inch mercury absolute. Yan. Tandaan nyo basic gauge na nga, may basahin nyo sa absolute. Okay? Engine efficiency is 78% and the combined mechanical and electrical efficiency is 95%. A. Find the RCR. B. Theoretical steam rate. C. Actual steam rate and the steam flow. And E. Is the exhaust enthalpy. So, the mga required dyan sa performance ng turbine. Okay? Alam mo yung yan. Okay, kasi yung exhaust enthalpy, kailangan mo yun kasi isusupply mo rin yan sa condenser o sa ibang equipment. So given this 2,600 RPM, 6,000 kilowatt, 385 PSI gauge, 800 Fahrenheit, 1.5 inch mercury absolute, engine efficiency is 78%, combined mechanical and electrical efficiency is 95%, and so MD. The required A is RCR, B theoretical steam rate of TSR, C actual steam rate of SR, D steam flow, M sub S, E is equal to exhaust enthalpy, H sub A. Yeah. Solution at state 1, so check this figure 1, ito dito. Is 385 PSI against 800 Fahrenheit. Equal to R1 isentropic 9. Actual niya is 8. So S of 1 is equal to H of 1 is 1,407.17.1 BTU per pound. S of 1 is 1.68 times 0.4 BTU per pound Fahrenheit. So ang bilang non-visible basis mo at state 9, 1.5 inch mercury absolute. And S sub 2 is equal to S sub 1 isentropic. Then H sub 9 is equal to 925.6 BTU per pound. Now, ang isentropic is a straight line, straight vertical line. Yan. So, kaya ako minamandian yung mga drawing nyo kasi isentropic na nagkakaroon pa ng inclination. So, nagtatabingi. So, hindi na yun isentropic. So, pwede consider kasi tinawag natin isentropic. Pag gawin nyo ng mga figure, so sundin nyo yung tamang tawag. Pag isentropic, so straight vertical line sa phase diagram. Constant temperature, it's a horizontal line. Walang horizontal line na umaakyat. Okay? RCR is engine efficiency of the combined efficiency, which is 78% over 0.95 is 82.1%. Letter B, TSR is 3413 over H1 minus H9. The TSR is equal to 3413 over 1417.1 minus 925.6 is 6.95 pounds per kilowatt hour. Letter C, TSR is equal to TSR over engine efficiency is 6.95 over 0.78 is 8.91 pounds per kilowatt hour. Ngayon natin So, D, walang magbibigay ng horsepower. Kasi ang natin is generator. The steam flow is equal to SR times kilowatt output is 8.91 times 60,000. 8.91 is pounds per kilowatt hour. Multiply mo ng 60,000 kilowatt, magiging pounds per hour unit mo. Is 534,600 pounds per hour. E, RCR is equal to H of 1 minus H of 8 over H of 1 minus H of 9. Solve for H of 8. Insert value and 0.821 is equal to 1417.1 minus H of 8 over 1417.1 minus 925.6. Therefore, S of 8 is equal to 1013.6 BTU per pound. So, ito kasi ang actual niya is hindi naka-prime. Ang theoretical niya, asymptotic niya is naka-prime. Sundin natin. Okay, so now dito tayo sa winner's line. The total steam required by the turbine, of course, can be found from the product of load and steam rate, and when batted against the load, becomes a winner's line. Figure 21. The three cases of governing that were shown for steam rates are used for this figure. Itong cases na to, meron tayong infinite Saka pinit. Ito yung pinit. Okay. Ito. And the same reasoning can be applied to Wheeler's line. Note that Wheeler's line for total governing and for an infinite number of governor is a straight line and will conform to the linear equation. So ito yung total governing, ito yung infinite number of governors, ito yung finite. So y is equal to a plus bx, where y is the total steam flow transfer out, a is the no load steam consumption transfer out. Dito siya tumama. No load, zero load, may value siya. So B is the slope of the curve, pounds per kilowatt hour. X is the load per kilowatt. Yan, units ang units. So example number 11, a 7,000 kilowatt turbine, 435 pesos, absolute 720 Fahrenheit, and 1 and 3/4 mercury absolute as the following steam rate. We have 7,000 kilowatt is 10.47,000 kilowatt. Ito yung steam rate niya. 10.88 pounds per kilowatt hour. Sa 6,400 kilowatt, 10.86 pounds per kilowatt hour. Sa 5,800 kilowatt, ito yung 10.5 pounds per kilowatt hour. Sa 1,020 kilowatt, this is 14.03 pounds per kilowatt hour. Estimate the no load steam flow by drawing the Wheeler's line and putting it to zero load. Use large scale. So kaya nang malakas dito. Para malinaw. So given, so yun nga, 7,000 kilowatt turbine, 435 pesos absolute, 750 Fahrenheit, and 1 and 1/4, 1 and 3/4, mercury, inches of mercury absolute. So sa 7,000 kilowatt, meron 10.88 pounds per kilowatt hour. 6,400 kilowatt, meron 10.86 pounds per kilowatt hour. Sa 5,800 kilowatt, meron 10.5 pounds per kilowatt hour. Sa 1,920 kilowatt, meron 14.03 pounds per kilowatt hour. So required is the no load steam flow. Solution, use the Wheeler's line. Then, i-plot nyo to. Yan na tayo. Sa X in kilowatt, 7,000 plus 4, 5,8, 192. Then, yung Y mo, value is, ano? Y is the total steam flow pounds per hour. So, you multiply mo yon. 7,000 times 10.88, 7,000 kilowatt times 10.88 pounds per kilowatt hour, magiging 76,160 pounds per hour. Same, 6,400 times 10.86, magiging 69,504. Then 5,800 times 10.5 is 60,900. Then 1,920 times 14.03 is 26,938. Then i-plus nyo to. So maraming online plotter, so sana marunong kayo gumamit. Then curve fitting. Okay? So make a curve fit. Sa calculator meron, di ba? Linear regression. So ito. So, yung mga value mo, i-plot mo yung 7,000 andito, papasok doon sa 76. So naman 6,4 andito. Yan. Dapat accurate yung drawing niya. Kasi pag dito pa lang may iba sa inyo, hindi na equal ang spacing. Okay? Dapat equal niya kasi equal lang value. Increment. So yan. Tapos, i-curve fit niya, gagawa kayo ng straight line niya. So, makuha niya ng value dito. So, curve fitting, y is equal to 8160.8 plus 9.5098x. Yan. Ito yung line na papasok dyan. So, at no load, steam flow. So, i-zero mo yung x. So, that x is 8163.8 is equal to plus 9.5098 times 0 is 8160.8 parts per hour. This is now your answer. Okay. Next, condenser. So, some published test result on large condenser will be given in the next example to illustrate the testing of this unit for heat transfer. So, example tayo. Example number 12. On a certain 5,110 square meter condenser in heat transfer area, the averages of periodic reading taken during 2-hour test at steady load are as he reported. The overall coefficient of heat transfer is to be computed. So the barometric pressure corrected to 15.6 is 770.9 millimeters mercury. Metered steam flow to total is 42,526 kilograms per hour. So vacuum at neck of condenser is connected to 15.60 is 751.3 millimeter mercury. Condensing water at 8.94 C out at 15.33 C. Condensing water quantity is 335,400 liters per minute. Given A is equal to 5,110 square meter, mass flow rate is, I'm so best din kasi steam yan na naging order. 42,276 kg per hour. Barometric pressure connected to 15.6 C is 770.9 millimeter Hg. This is barometric. So ito namang vacuum at neck of condenser connected to 15.6 C is 751.3 millimeter of mercury. Condensing water quantity is 335,400 liters per minute. So ito yung condensing water, yung ginamit na tubig para mag-condense yung steam ito. So entering at 8.94 C and 15.33 C, ang symbol na is TW1 and TW2. So the required is U is equal overall coefficient of heat transfer. Solution. The formula for heat transport is Q is equal to M sub W times C PW times TW2 minus TW1. So M sub W, ito pala yun, 335,000 liters per minute. So this is M sub W is equal to 335,400 liters per minute. So convert per second. This is 1 kilogram per liter times 1 minute over 60 is 5590 kilogram per second. This to assume na ang density ng water is 1 kilogram per liter. Sige, test na to. Malapit na siya sa value dito. Average nito, kunin mo yung relative level ng density niya. Yan din yan. Ang baba ng ano, di ba? Pag pataas yung temperature, so tingin ka relative level. So this is, since this is within the range, so pwede yung 1 kilogram na. Pwede kahit i-check niya. So CPW is 4.27 kilojoule per kilogram per second. Correct. Kung mataas yung temperature, mag-ibang value. Then Q is equal to 5590 times 4.17 times 15.33 minus 8.94 is 149,560 kilowatt. So steam pressure sa condenser is the vacuum yung vacuum pressure gawin mo absolute. So that is the barometric pressure minus the vacuum pressure. So the 770.9 minus 751.3 is equal to 19.6 mm mercury at 15.6 or same as 19 millimeter Hg at 0 C. Yun ang value niya. So para magkuha mo sa ito. So the saturation temperature is equal to 21.82 C. From steam table, so makita mo yun doon. Kasi walang available 15.6 ito, that is kasi approximately equal niya. So the required is the overall heat transfer coefficient. Galing siya sa Q is equal to U8 theta M. This is the log mean temperature difference. So theta M is equal to TW2 minus TW1 over ln of Ts minus T sub W1 over Ts minus TW2. So saturation to, di ba? Kaya required. Para siya up and down. This will become 15.33 minus 8.94 divided by ln of 21.82 minus 8.94 over 21.82 minus 15.33 is 9.32 C. So the period of transfer. Therefore, U is equal to Q over A theta M is equal to 149,560 over 5,110 over 9.32 is 3.140 kilowatt per meter squared Kelvin. This is my answer. Kilowatt, may malibong nito. Bakit kilowatt? Hanapin natin. Kilojoule. So that's kilowatt. Okay. Next, speed pump. The purpose of pump is to move a quantity of water against a pressure. Essential to any quantitative discussion of performance, capacity, etc. on the following terms and definitions. So ito yung sa speed pump. Kailangan mo ng pump discharge in GPM, Q. Then S is equal to the head, the feet of water of specified density. At ordinary temperature, density is 62.4 pound per cubic foot. Gamma W is the water density in parts per cubic foot, reciprocal of piece of the Brownston table. So static head is the height, usually in feet, of the surface of the water above the gauge point. Pressure head is the head, static head plus gauge pressure on the water surface plus friction head. Velocity head is the head required to produce a flow of water. Dynamic head is the pressure head plus the velocity head. So the total discharge suction head is the reading of a true gauge at the pump discharge of suction converted to fetal liquid and referred to atom plus the velocity head at the point of gauge attachment. If the suction head is less than atmospheric, it is negative. This is because the existence of suction lip causes the gauge to read vacuum at its negative gauge pressure. Next, pump operating head is the algebraic difference of discharge and suction head. This can also be called the total dynamic head and abbreviated as TDS. Net positive suction head, abbreviated NPSH, is defined as the dynamic pressure of the liquid at the pump suction, PSIA, less than the saturation pressure corresponding to its temperature at the same point converted to feet head of water. Specific speed, so yan, of a centrifugal pump impeller is rotating at which a geometrically similar impeller would run if it were of such size as to raise 1 GPM against 1 foot head. So this is the definition of a specific head. So tandaan nyo yung unit, and it's the pump of speed, RPM, S, TDS, and feet per stage. Okay, here is the discharge in GPM. So for 2-stage pump, so divide mo yung head ng dalawa. The specific speed is useful in defining the suction limitation of impellers of different designs. May table yan. So, okay tayo dito. Sa fluid mechanics na yan. Then, the water horsepower or hydraulic horsepower is WHP is equal to QH over 1060. So, ito yung derivation niya. But, for meantime, W is weight moving pounds per hour. H is the developed horsepower. Itong W to, hindi ito yung W, So 8.33 is equal to weight of 60 pound water, pounds per gallon. Diba? 8.33 pounds per gallon. So ito yung gagamitin natin. Pero iba dyan, 8.34 kasi 8.33 above yan. So 8.33 tayo. Specific gravity of the is PGR is specific gravity of the fluid referred to water at 60 Fahrenheit. Q is gallons per minute. Pump efficiency is the water horsepower divided by the brake horsepower. Kasi mas malaki yung brake horsepower mo. Input yan. Input. Idadrive mo yung pump galing sa mechanical drive. So may wala. May wala. Okay. Tanggalin natin to. Ito. So yun. So, dito lang na yan. Kasi marami pang topic yan. So, huwag natin idagdag yan. Baka maubos ang ulas natin dito lang tayo sa pump ko. Example number 13. So, ito yung problem. The drive requirement of the pumping installation diagram in figures shown are analyzed. Data. Velocity in suction line is 2 meters per second. Dito. This is your pump. Ito yung suction. Discharge line, ito, yung velocity naman niya is 3 meters per second. Friction estimate in suction line, including foot valve instance loss, kasama na lahat dyan, is 0.65 meters. In discharge line is 0.75, kasama yung mga fittings. Using the center line of the pump platform, this is the center line of the pump, total head is calculated. Assume gauge attachment 300 mm below datum. Ito yung gauge 300. So, wala pinakitang gauge dito. So, yan. Assume gauge attachment 300 mm below that rope. So, dito yung mga gauges sa baba. Okay. So, given velocity in suction line 2 meters per second, discharge line 3 meters per second. Friction line estimate, friction estimate in suction line including foot valve and friction loss is 0.65 meters. In discharge line, this is 0.75 meters. Flow is to be 3,800 liters per minute cold water. Pump efficiency is 0.65. Assume gauge attachment 300 mm below that too. Required. So drive requirements, the BSG. So iba yung required na standard is calculated. Okay. So, okay, dinagdag ko lang dito. Type requirement. Solution, based on dito sa suction velocity is 2 meters per second. Based on D is equal to 3 meters per second. The friction loss is H of Fs equal to H of F to foot valve equal 65. H of F to discharge is 0.75. Q, yeah, liters per minute. Pump efficiency is 0.65. Then sa equation mo, ito, di ba, sa Bernoulli, kailangan mo ng C sub D, which is 4.5 plus 0.3. Ito yung nasabing 300 mm below that tube. Si discharge 4.5, and ito yung 4.5 plus 0.3 is 4.8. Dito naman, C sub D is negative of the time ito. 2.5 minus 3. Yung ano, so with reference gauge, so ito yung C sub D is equal to 4.5 plus 0.3 is 4.8 kasi dito yung gauge mo. Ito yung reference mo na. 4.5 plus 0.3. So C sub S is negative sa baba. Negative times 2.5 minus 0.3, which is now negative 2.2. The discharge side is equal to C sub D plus P sub D squared over 2G plus H sub FD is equal to 4.8 plus 3 squared over 2 over 9.85 plus 0.75 is 6.01. 3. Discharge. Suction head is C sub S plus P sub S squared over 2G plus H sub Fs is negative 2.2 plus 3 squared over 2 over 9.81 minus 0.65 is negative 2.65 meter. So the pump operating head difference is 6.01 minus negative 2.65 is 8.66 meters. This is the answer for the total head. And calculating power, so available natin is QH over 1060, so convert this to English units per cube. Is 3,800 liters per minute times 1 cubic meter per 1,000 liters times 3.281 feet per meter cube times 12 over 12 inches per 1 foot cube times 1 gallon over 21 cubic inch is 1,004 GPM. So the head is 8.66 times 3.281 is 28.4. Then the water horsepower is QS over 1060 is equal to 1,000 plus 28.4 over 1060 is 7.2 horsepower. Mayroon tayong pump efficiency. So PHP is equal to water horsepower divided by pump efficiency or 7.2 over 0.65 is 11.1 horsepower. So yeah. So next, the capacity, the discharge capacity of ito sa centrifugal. So dito tayo sa next is the piston displacement. The discharge capacity of a positive piston displacement equipment is the piston displacement multiplied by the volumetric efficiency, where the latter includes the effects of slip and piston rod displacement, volumetric efficiency. When N sub B is the volumetric efficiency, should be more than 90.94 pumps in good order, not over-speeded. Bar PD is the piston displacement in cubic meter per minute per pump. Then commercial pump speeds are approximately V sub P is equal to 1.38 times the square root of L in meters per minute of piston speed, where L is stroke in millimeter. Okay, yung mga units niya, this is for use with cold water and should be reduced by multiplying air factor if hot water is pumped. This factor is 0.85 for 22.2 C water, 0.71 at 65.1 C, and 0.46 at 204.4 C. It can be considered to vary linearly with temperature. So, pwede ka mag-interpolate dyan. Okay, so this is the end of this topic.